Okay, so in our lectures to this point, we've talked about the universe expanding from a singularity, what we call the Big Bang. As it expanded, then forces separated out. We began to get the individual forces, the freezing out of those forces, overshooting what we call a false vacuum or supercooled state. As the strong force freezes out, you get inflation. The universe rapidly expands. And then you start making more particles, and you start eventually getting nucleosynthesis, creating the very first atoms, very first nuclei rather, and then recombination. Really, as I have said before, it should be called combination, and that creates the first atoms, in which the electrons get grabbed up by the nuclei, and now you have the first atoms. You have the dark epoch, not much is happening there. The universe is simply expanding. You get a swarm of atoms. As they're cooling off, the universe goes from visual to infrared. Nothing is visible. Finally, get the first stars, and then more stars, and yet more stars, and then a whole bunch more stars. The stelliferous era. And so we're still in the stelliferous era. We're still making stars and galaxies. Galaxies are still coming together and colliding. As I'd said earlier, the Milky Way is still probably in the process of forming. We got these clouds of gas spiraling into the galaxy. We've got the Andromeda Galaxy on a collision course with us. Eventually, the entire local group will be swallowed up into one big, what we call fossil cluster, and so, or fossil group. And so that's going to be the entire, that the whole thing. Okay, and so the next question: what about the future of the universe? Two possibilities. One possibility, and what was the leading idea when I was in college, was the universe will expand to a point, gravity will win, it will stop the expansion, the entire universe will fall back in on itself, what we call the big crunch. Essentially, the whole universe squeezes back into a singularity, and as it gets hotter, squeeze and squeeze, hotter and hotter and hotter, back to a singularity, we get a hot end. Okay. What happened at that point? They kept arguing. They said, does the universe just like start, stop, and then we're done? That's it? Or does it squeeze into a singularity, which then expands to another universe, the big bounce? And so an oscillating universe. And so there were speculations there may have been like nearly infinite number of universes before ours, that ended as a singularity. Then ours became the next universe, and then ours will end as a singularity, and another universe will form. So that was one possibility, and that was kind of an idea they kept arguing about. The other possibility was it never stops expanding, it keeps going forever. Again, we seem to have right that critical density, and so they were arguing about that possibility. In which case, something called the heat death of the universe happens, and things get so far away from each other as the universe expands that things quit interacting. And so if they quit interacting, then nothing else ever happens, and so the universe kind of dies of boredom. And so these were the two competing ideas. Well, the problem is dark energy makes the universe accelerate the expansion. If we're accelerating expansion, then that means we're not going to slow down, and we're not going to go into a big crunch. No bouncing universe. We are in fact going to expand forever. So let's go into what does that mean. Well, we're in the stelliferous era right now. So as the universe expands, what's going to happen is we're using up interstellar medium to make stars. Eventually, we're going to use up all the interstellar medium and not many stars to make. And so the stars that are there are eventually going to die. And even the little red dwarfs are eventually going to run out of steam, and they're going to die. And so eventually, all that's going to be left of the universe are white dwarfs, neutron stars, and black holes. And there'll be a few stray particles out there. Eventually, the universe is going to expand so that everything outside of our local group has expanded away from us, and we can no longer interact with it or even see it. Again, the bigger the space between us and there, the faster it expands, and so eventually the local group's going to be the entire universe. And so what makes up the local group will be held together by gravity and make just a fossil cluster of dead things. White dwarfs, neutron stars, black holes, and then just a few stray particles. Eventually, though, protons will decay. They're not going to last forever. And so white dwarfs are going to decay into neutron stars. Eventually, neutrons will decay. And so neutron stars will collapse into black holes. So there'll be nothing left except for black holes. We call that the black hole era. Now, black holes will last for a really long time, but eventually Hawking radiation will cause them to decay. So after 10 to 100 to 10 to 150 years, there's not even a name for numbers that are that big. So these are ridiculously huge numbers. After that amount of time into the future, though, then Hawking radiation will have decay, would have caused all the black holes to decay. Well, now you have all these individual particles spewing out, particles or radiation, but those particles are now so far away from each other, they're never going to come back together to fuse or do anything else, and we know that they will eventually decay themselves. They're going to decay, and eventually all that's going to be left is light, photons. Well, the problem is the universe will keep expanding, and as the light's traveling across the universe is expanding, and so the wavelengths get longer and longer and longer. Well, if you stretch it long enough, you stretch it to a straight line, and then it's not a photon anymore. It's not light anymore. Eventually, you're going to stretch everything into nothingness. The entire universe will become nothing, just empty space with nothing in it. And that is what we call the heat death of the universe. It's really the term heat death comes from Lord Kelvin, who suggested back in the 1800s that what would happen is that heat goes from hot to cool, and that drives engines, drives energy. By moving energy from one place to another, you're able to do work. And so, but he suggested what would happen is entropy would eventually dominate, and eventually what would happen is that everything would be the same temperature. And if everything's the same temperature, energy doesn't travel anywhere, and things just kind of quit happening, and everything just sits there. And so that was his idea of heat death. The modern idea of heat death of the universe, in which everything is stretched to nothing, makes his ideas actually seem pretty tame. So the modern idea is the universe ends empty with nothing. The end of the universe and everything, and the class for that matter. So this is the final lecture. Kind of wish we were in class in person to do this. This transition to being online has been difficult for everybody, and I do miss seeing everyone, and wish y'all well. And hopefully I can see y'all at some point in the future in person on campus.